so justifying that log base b of x times y equals log base b of x plus log base b of y. So I'm kind of starting with the right-hand side of this equation, right? And I'm going to kind of work my way back. So I'm going to let m, which is just some number, represent log base b of x. And log base b of y, that's some number, I'm going to call it n. All right, so now that arrow means implies. I'm going to apply the definition of a logarithm to these two equations. So if m equals log base b of x, how do I change that to an exponential equation? What exponential equation is equivalent? B is the base, m is the exponent, and that should equal x. And then the other one, when I change that, I get b to the n equals y, right? So now I have expressions for x and for y. So I can look at log base b of x times y, and I want to see what that equals. And log base b of x times y, I'm just going to make a substitution. I'm going to replace the x with a b to the m and replace the y with a b to the n. So log base b of x times y is log base b of b to the m times b to the n. Now, what is the rule when you are multiplying like bases? B to the m times b to the n, what would that equal? M plus n, b to the m plus n. So this is log base b of b to the m plus n. All right, what is that? Log base b of b to the m plus n, what does that equal? Yeah, so x would have to be m plus n. Yep. So when you do the log of something, you ask yourself, okay, b is the base, right? B to what power would give me b to the m plus n? The m plus n. Yeah. So if that's not clear to you, right, you can write it out. When you're here at this step, you could say, okay, this equals something that I don't know. I'll call that thing x, and this says b to the x equals b to the m plus n. And then you go, oh, x is m plus n. It has to be m plus n. Okay, but m is log base b of x, and n is log base b of y from the very first step of my proof here. Log base b of x plus log base b of y. So we have proven it. Log base b of x times y equals log base b of x plus log base b of y. And it's because logs are related to exponents, right? And we have rules of exponents. When you multiply like base, you add the exponents, which means you're going to add the logs, because logs are exponents. So you can do a very similar proof on part B. So I'm going to leave that to you. LTR means left to reader. You can do that proof on your own. All right, let's take a little look at part C here. Log base b of x to the p. So this, I'm going to use the definition of an exponent, means repeated multiplication, right? X to the p means x times x times x times x, p times. So this says log base b of x times x times x, p times. And then I'm going to apply property A. when you take the log of a product, it's like you can distribute the log and change it to a sum. So this says log base b of x plus log base b of x plus log base b of x. And how many of these log base b of x's am I adding up? P of them, because I had P of them up here. P of these. And how do you write adding something to itself P times? Multiply. Repeated addition is multiplication. That's the definition of multiplication. So this says P times log base b of x. So we showed that they are the same. Raising log base b of x to the p, you can take the p that's in the exponent and put it down in front of the log. Very handy little trick. All right, let's look at part D here. Log base b of x. This is called the change of base property. Okay, so if I have base b, I can change it to any other base I want by taking log base a. The a is my choice. Log base a of x divided by log base a of b. So one good thing about this is that you only have two log buttons in your calculator, log base 10 and log base e. So now, with change of base, you can change anything to using log base 10 or log base e, so you can do it in your calculator. But first, I should show that this is true. So if I write y equals log base b of x, how do I change that to an exponential equation? B to the y equals x. And then I'm going to take log base anything I want of both sides, right? So if I take, let's say, the ln of b to the y, that would equal the ln of x, right? General property of equations, you can do anything you want as long as you do it to both sides. So I could take the ln of both sides. I could take log base 17 of both sides. Any log I want. Just for demonstration purposes, I'm going to do ln. All right. Then, on the left side of this equation, I'm going to apply property C. This is ln of b to the y. Property C says that when you take the ln of something to an exponent, you can take that exponent and bring it down in front. So this says y times the ln of b equals the ln of x, which means that y is the ln of x divided by the ln of b. And so that is how I change the base, right? I started with y equals log base b of x, and it became ln x over ln b. So you can change to any base you want using this change of base formula. All right, so that was a lot of theoretical justifications. I'm not going to hold you responsible for explaining why these are true. I just feel like it's important to show you at least once so you know that they come from somewhere and I didn't make them up, right? Okay, so now what you are responsible for is using them, using these rules. So I want to combine this expression, log base 4 of 2 plus log base 4 of 32, into a single logarithm. Okay, so let's look at property A here. I'm kind of going backwards. I'm saying, oh, look, the thing they gave me looks like this. I'm adding two logs together that have the same base. That means I could write them as a single log where I multiply the two inputs together. So I'm going to write log base 4 of 2 plus log base 4 of 32. That is log base 4 of 2 times 32, which is log base 4 of 64, which would be what? An alternative way of saying what is log base 4 of 64 is asking yourself 4 to what power is 64? The third. Yeah. 4 to the third power is 64. So that comes out to 3. Yes, when I have base 4, that's the base in the exponential. So this is a log base 4. So that means 4 to the what gives you 64. Yeah. All right, so let's use the property of the logarithms. Again, we're just practicing to evaluate log base 3 of 81. So the first way I could do it is to use the definition, right? Log base 3 of 81 is asking you 3 to what power gives you 81? The fourth power. Done. Right? Or 81 is a special kind of number. It might pop out in your head as what? A perfect square, right? So I might write this as 9 squared, right? It doesn't matter. 81 and 9 squared are the same, right? I'm not done yet here, but once I've written that as 9 squared, I could use property C up here, right? If I take the log of something to a power, you can take that power and put it down in front of the log and treat it as multiplication. So I could write this as 2 times log base 3 of 9. And what is log base 3 of 9? 2. Yeah. So log base 3 of 9 is saying, what do you raise 3 to get a 9? 2. So 2 times 2 is 4. Same answer I got going directly. All right, again, I'm going to use properties of logarithms to evaluate this expression 2 ways. Actually, I'm going to go back to 3 for a second. Go back to 3 for a second. I'm going to do this a third way. Log base 3 of 81. Let's say, oh my god, I have no idea what log base 3 of 81 is or how to figure it out. Right? If I know the change of base formula, I know I'm going to do it a third way. I could use the change of base formula to write this as the ln of 81 divided by the ln of 3. Or log of 81 divided by the log of 3. If I type either one into my calculator, ln 81 divided by ln 3, I get 4. Same thing when I did it my other 2 algebraic ways. Log of 81 divided by the log of 3, 4. So you can also use the change of base formula to do that one. Yes. 3.99 continuously. Well, you have a silly calculator. Yeah. Yep, okay, so apparently this calculator is doing some kind of numerical method, and it's not getting the exact answer. You can never trust a calculator. This is the only calculator you can trust. All right, number 4. Again, I'm going to do this problem in 2 different ways. Log base 2 of 4 cubed I can use property C, and I can take that exponent and bring it down in front of the log. So this would be 3 times log base 2 of 4. And what is log base 2 of 4? 2, because log base 2 of 4 means 2 to what power gives you 4? It's 2, so we get 6. Or I could do this problem directly. I could say, okay, now I'm doing log base 2. 4 cubed is 64. So what would I raise 2 to make a 64? The 6th power? I think that's right. Yeah, the 6th power. Well, I should know because I know the answer comes out as 6 because I did it the other way also. And then I can check on my calculator, right? Log base 2 of 64 should be the ln of 64 divided by the ln of 2. Does give me 6. Or 5.9999999 if you're using an HP. All right, so there's the change of base formula. We did it as we went, checked our answers to 2, 3, and 4. Yes. Yeah, that's a great question, and we're going to talk about it on Wednesday. You use it when you're trying to solve an equation that looks like, say, let's say I wanted to solve 2 to the x equals 72, something like that. So you would say, ooh, 72 isn't a perfect power of 2, right? Like 2 to the 6th is 64, but 2 to the 7th is 128, so it's somewhere between 6 and 7. So what you can do is you can take the log of both sides. So this is like sort of this magical thing, and now that we have this property where you can take the exponent and put it in front, now I don't have the problem of the variable and the exponent anymore. ln2 is just a number. ln of 72 is just a number. So I can just divide both sides by ln2. And we get x equals ln 72 over ln2. And my calculator can do that. And I get 6.17, which I knew it should come out somewhere between 6 and 7. So it turns out to be 6.17. So having these properties of logs, the purpose is to be able to solve equations where the variable shows up in the exponent. And we'll do lots more of these on Wednesday. Okay, so this gets over at 2:10. So I want you to spend like 10, 15 minutes working on this activity. So I would do like maybe the first 2 from each section. So some where you expand, a couple where you're condensing, and then a couple where you're doing the creative thing. And you have the answers so you can check your work.